Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, the most merciful. Dear students, Assalamu alaikum. My name is Ayesha Abdullah, Subject Specialist Maths at Divisional Public School and College Sahiwal. Students, I'll teach you Maths of Class 6 and this is your lecture number 15. As you already know that we are studying chapter number 8, Introduction to Algebra. So here is the content. Include exercise 8.6 question number 2 to 6. By the end of this topic, you will be able to evaluate and simplify an algebraic expression when the values of variables involved are given. In previous lectures, you have learned about the process of finding the numerical value of an expression by using numbers in place of variables. This process is called evaluation. Students, numerical value is a number regardless or irrespective of its sign. Evaluation is a term that is used in algebra. But how? Let's understand or recall this process through different examples. Here is an example, that is, evaluate a plus b if a is equal to 1 and b is equal to 2. To evaluate an algebraic expression means to find the value of the expression when the variable is replaced by a given number. So in solution, to evaluate an expression a plus b, we substitute the given number 1 for the variable a and 2 for variable b as, and we write plus sign as it is in the expression, and then simplify the expression 1 plus 2. By adding 1 and 2, we get 3 and this is the answer. Let's take another example in which we have to evaluate the expression a minus b plus c when a is equal to 2, b is equal to 1 and c is equal to 1. In solution, to evaluate this expression, substitute 2 for a, 1 for b and 1 for c and write the signs as it is between the variables and then simplify. Now you can see that minus 1 and plus 1 will cancel out as we are subtracting same number with opposite signs and we are left with 2. So this is the answer. In this example, we have to evaluate the expression ab plus bc when a is equal to 2, b is equal to 1 and c is equal to 1. In solution, remember that ab means a times b or a multiplied by b. To evaluate the expression ab plus bc, we substitute 2 for a and 1 for b and we insert multiply sign between them as ab means a multiplied by b. Similarly, we substitute 1 for b and 1 for c and we insert multiply sign here between them as bc means b multiplied by c. You have to insert plus sign as it is between these two terms. Now we have to simplify this expression using the order of operations. Means you have to care about this Bodmas rule before solving such expression. Bodmas is a short form for brackets of division, multiplication, addition and subtraction. This rule explains the order of operations to solve such expressions. According to Bodmas rule, in a given mathematical expression that contains combination of signs, brackets, multiplications of addition, subtraction, division, we must first solve or simplify the brackets followed by of, then division, multiplication, addition and subtraction from left to right. So using this rule, we have to multiply numbers first before addition. So 2 multiplied by 1, we will get 2 here, and 1 multiplied by 1 will get 1 here as. Now we will insert plus sign as it is. You can see that 2 plus 1, that will be equal to 3. And this is the answer. So, in this way, we find numerical value of an expression by using numbers in place of variables. And this process is called evaluation. You can see that here as. Students, remember that simplifying such expression, you have to use Bodmas rule carefully. Solving the expression without Bodmas rule or from right hand direction give you a wrong answer. So you have to care about Bodmas rule before using. So here is the topic, exercise number 8.6, question number 2 to 6. Question number 2 is given over here, that is, if a is equal to 5 and b is equal to minus 3, then prove that a plus b is equal to 2. In solution, as you can see that left hand side is equal to a plus b. Now substitute 5 for a and minus 3 for b as, and write the plus sign as it is. We'll insert bracket here to avoid any ambiguity. Now here you have to use multiplication integers rule. That is, product of a positive and negative integer is negative. We will remove the bracket by multiplying plus sign to minus 3 as, or you may say that we have to multiply plus 1 by minus 3. In this way, we will get minus 3 as. After removing the brackets, we will get here minus 3. Now 5 minus 3, that will become plus 2. Or just 2, which is equal to right hand side. So now you can observe that left hand side is equal to right hand side. Hence proved. Question number 3 is given over here, that is, if a is equal to 1, b is equal to 1 and c is equal to 9, then prove that a minus b plus c is equal to 9. In solution, as you can see that left hand side is equal to a minus b plus c, we substitute 1 for a, 1 for b and 9 for c. And write the signs as it is between these terms. Now, plus 1 and minus that will cancel out, as we are subtracting the same number with different signs. So we are left with only 9 as, which is equal to right hand side. So in this way you can see that left hand side is equal to right hand side and hence proved. Question number 4 is given over here, that is, if A is equal to 10, B is equal to minus 10 and C is equal to 4, then prove that A multiplied by B plus 25C is equal to 0. In solution, as you can see that left hand side is equal to A multiplied by B plus 25C. Now we substitute 10 for A and minus 10 for B. We will insert bracket here to avoid any ambiguity. Now for solving this expression, we must care about Bodmas rule again. We first multiply plus 10 and minus 10. Here you can see if no sign is shown, the number is automatically considered positive. Here we'll use multiplication integers rule, that is, product of a positive and negative integer is negative. So we write minus sign here and 10 multiplied by 10 will get 100. So we write minus 100 here. Write plus sign as it is. Now 25C means that 25 multiplied by C. So you have to substitute 4 for C as 25 multiplied by 4, that will become 100. And we'll write plus sign as it is. In this case the result is 0 as we are subtracting the same number with different signs, which is equal to right hand side. And you can see that left hand side is equal to right hand side and hence proved. Question number 5 is given over here, that is, if x is equal to 1 and y is equal to 1, then prove that x plus y whole square is equal to x square plus 2xy plus y square. In solution, left hand side is equal to x plus y whole square, as you can see that. Now we'll substitute 1 for x and 1 for y here in this expression and we'll insert whole square of this expression as it is. Now 1 plus 1 is 2 and we'll get 2 square as. Students, to square a number is just multiply it by itself. As you can see that 2 square means that we have to multiply 2 by itself. So 2 multiplied by 2, that will be equal to 4. So we write here 4 as. Right hand side is given over here, that is x square plus 2xy plus y square. We'll substitute 1 for x and write here 1 square as. Now we'll write plus sign as it is. Students, 2xy can be written as 2 multiplied by x multiplied by y. Students, 2xy can be written as 2 multiplied by x multiplied by y. Now substitute 1 for x and 1 for y in this way. We will get 2 multiplied by 1 multiplied by 1. This expression can be written in this way using brackets and you'll get the same answer. Now insert plus sign as it is and substitute 1 for y. In this way we'll get 1 square as. As you know that 1 square means we have to multiply 1 by itself. In this way we'll get the answer 1 as. So we write 1 here. plus 2 multiplied by 1 multiplied by 1, we'll get the answer 2 in this way. So we write 2 here as. Again write plus sign as it is, and 1 square means you have to multiply 1 by itself. In this way you will get the answer 1 again. Now 1 plus 2 plus 1, that will be equal to 4. And you can see that left hand side is equal to right hand side. Hence proved. Here is an assignment for you, question number 6 of exercise 8.6, which is very similar to question number 5. Thank you so much for watching the video.